Hello engineers, welcome to the new video of the course, and in this particular video we are going to see that how exactly the second parameter, that is length, affects the overall impedance or the resistance of any material, right? If I increase the length, then how exactly it influences the resistance of that particular material or of that particular conductor, right? So in the previous session we saw the first parameter, that was area. So area was inversely proportional to the resistance, meaning is that if the area increases, the resistance of that particular material was decreasing, right? But what will happen if we increase the length? Okay, and again we'll assume same thing, that is, let's assume that my I is moving in this particular direction. Okay, if my current is moving in this particular direction, for sure the electrons will move in this particular direction, right? Sorry. Okay, and what we know is that my L2, it is greater than my L1. Okay, so this is what we know. Let me just highlight this particular point. So this is what we know. Okay, and since my L2 is is greater than L1, right? So obviously the nucleus, okay, you see they're also going to double. Okay, so what I meant to say is that if you see very clearly, if I take this particular thing out over here, okay, and if I put it somewhere over here, right, so it looks exactly similar. So what if I say that L2 is almost 2 times of L1? So this is what it means. So you see this, there were two nucleus over here, so I'm showing same two nucleus over here as well, right? And since current is moving in this particular direction, so the electrons should also move in this particular direction. And there is another important point, that is the area of this particular conductor is same, right? So if you could remember when we were dealing with the previous case where we were changing the area, okay, but if you see, we were not playing with the length. The length was constant, right? Just the thing was that we were increasing the area, right? A2 was greater than A1, right? But if you see the length was same, right? Similarly over here, in case of length, what we are doing, we are not playing with the area, we are just changing the length, right? Okay, so let's see what happens. But before that, let me ask you that according to you, what will happen, whether the resistance will increase or it will decrease? So it's my request to you all guys that you please pause this video and try to think. Alright, I believe that you all guys have tried your best. Now it's my turn. So what we'll do same assumption. Let's say if I have 10 electrons over here, right? If I have 10 electrons somewhere over here, okay, and obviously if 10 electrons are coming over here, so this same 10 electrons will be present over here. Why? Because the area is same, right? Since the area is same, so therefore the number of electrons that are coming, that they will be same, right? They will be constant because area has not increased. I hope you are able to understand this. So let me just write that particular point. Okay, since area is constant, right? Area is constant, therefore number of electrons entering will also remain constant. Therefore number of electron entering or incoming electrons will also remain constant, constant. Hope this particular part is crystal clear. Okay, now just try to think what will happen. Again same thing what we saw over here. So you see what happened over here. If 10 electrons are coming, so out of 10 only 6 electrons were able to come over here. So almost same thing will repeat over here for this particular scenario. Okay, so if there are 10 electrons, I'll just write over here, if there are 10 electrons, let's say if the incoming electrons are 10 electrons, so there are 10 number of electrons that are coming. So out of those 10, let's say only 6 electrons are able to move out. Okay, 6 electrons per second are able to come out of this particular conductor, because obviously the 4 electrons will come in the next second. But why they didn't come over here? Because of the nucleus, these two nucleus, they changed the direction of that particular, of those 4 electrons, right? I hope you are able to understand this. But what will happen over here? Let's say again 10 electrons are entering. Just the thing is that L2 is almost 2 times of L1. Okay, so according to you, what do you think, how many electrons may come over here? Okay, how many electrons may come over here? Just pause this video and try to think. Okay, just pause this video and try to think. What will be the logic? Alright, I believe that you all guys have tried your best. Now it's my turn. So you see 10 electrons are present over here. Okay, 10 electrons are present over here. Let's say out of 10, 7 electrons came over here. Okay, or let's say 10 electrons came over here. Okay, 10 electrons came over here. Out of 10, let's say only 7 electrons or 6 electrons came up till here. Okay, why? Because these are the two nucleus. They will, just hold few of the electrons for certain milliseconds or for certain time. Okay, that is not the problem. Okay, but if you see, out of the 6 electrons, there are more 2 nucleus. So this 2 nucleus will change the direction of few of the electrons from this 6 electrons. So let's say at the output we are just getting, let's say, 3 electrons. So out of 6 electrons, only 3 electrons are coming per second from this entire conductor whose length is L2. I hope you are able to understand this. See, in both of the scenarios, the area is same. So the amount of electrons entering will be same. So 10 electrons are entering when the conductor has length L1. Similarly, 10 electrons are entering even though the conductor has length L2, right? But what happens over here? You see, there this 2 nucleus over here and this 2 one, right? So what we saw was that 2 nucleus are capable of changing the direction of 4 electrons. So this is what we saw roughly, not exactly, but we are just taking a rough guess. Okay, so 4 electrons got stuck somewhere over here. Okay, and 6 electrons moved forward, right? Out of these 6 electrons, they the moment they approach over here, again there were 2 nucleus. So only these 2 nucleus, they deflected the other three electrons, and the remaining 3 electrons, they came out of that particular conductor, right? So you see, as the length increases, the amount of electrons that moves which moves from point A, let's say this is point A to point B, it got decreased. I hope you are able to understand this particular scenario. Okay, I hope you are able to understand this particular scenario. Okay, I really hope that you are able to understand this particular scenario. If you are not able to understand this particular scenario, it's fine. Okay, I'm here to explain you in some different way. So let's assume that this is your football pitch. Okay, a pitch of football, and let's say you are standing somewhere over here. Let's say electron is the ball, right? Electron is the ball, and now you are shooting the ball. You are just shooting this particular ball or shooting this particular electron, right? So let's say if you shoot 10 electrons, right? If you shoot 10 electrons, out of this 10 electrons, few of the electrons, they stayed somewhere over here at this particular point. Okay, whereas few of the electrons, they moved forward. Okay, but they moved in this particular direction or in this particular direction, and very few of them, they managed to hit the goal. Let's suppose this is the goal post or goal. Okay, now what exactly is happening over here? Treat this particular nucleus as defenders. Okay, and if you see very clearly what exactly is happening over here, the moment you are hitting the ball, obviously the ball has certain velocity. After some time, the velocity of the ball is going to decrease, right? So same thing is happening over here. Velocity of electrons decreases after some point, due to which those particular electrons are not able to move forward, whereas very few of the electrons has certain energy, and thus they are able to move towards this particular goal post, okay, or goal, whatever that is. Okay, I hope you are able to understand this. Treat nucleus as a defender. Try to think as a footballer, right? You are shooting the ball, there are certain there are 4 defenders. Okay, let's say if you shoot if you shoot 10 balls, right? If you shoot 10 balls over here, out of those 10 balls, only 3 balls are able to go towards the goal. Okay, or they approach towards this particular goal. Why? Because let's say out of 10, let's say 3 of the balls, they were being deflected by these defenders, right? And few other balls, they stopped somewhere in between because the velocity of the ball got reduced. Okay, and the other balls, they got deflected by these particular defenders, and these 3 balls, they somehow managed to hit the goal or to approach towards the goal. I hope you are able to understand this. See, this is how you have to learn current electricity. Obviously we cannot see electrons. I mean, we can, but with the help of microscope and all. So we don't, since we don't have this microscope and all, so this is how you have to understand. You have to build certain analogy to understand the working of current, electricity, etc., etc., right? I hope you are able to understand this, right? This was very, very simple and basic example, and now I hope that you are able to understand this, right? If I increase the length of the football pitch, surely the velocity of the ball is going to decrease. This is the first point. Secondly, since there are certain defenders onto that pitch, so they are going to deflect that particular ball, they are going to defend that particular ball. In our case, the ball is electron, right? I hope you are able to understand this. This is very, very simple explanation. Okay, but still, if you are facing any doubts or any difficulties, do let me know in the communication section. Okay, so now let me just write few of the conclusions that we draw. Okay, first is, as length increases, let me just write over here, as length increases, what happens as length increases? We saw two things. First, the velocity of the ball, in our case the ball is electron, velocity of the electrons decreases, right? Velocity of electron decreases, okay, due to which the electrons are not able to approach at the end of the conductor. Okay, that is at point B. Okay, and secondly, the second thing is that set of nucleus, that means the defenders, okay, which are acting as the the nucleus which are acting as the defenders, right? So set of nucleus also increases, which results in decrement of electron flow. Okay, in other words, you can also see this in this way. Let's say if this is the football pitch of L1. If you are standing somewhere over here, you hit the 10 balls, there are just 2 defenders, and since the length of the football pitch is quite less as compared to the previous one, that is L2, so 6 balls, they move to this particular goal post, okay, or towards this particular goal, they approaches the goal. The remaining 4 balls, out of those 4, let's say 2 got stopped somewhere in between because the velocity of the ball decreased, and 2 of the balls were being defended or deflected by this particular defenders. Okay, I hope you are able to understand this particular point. It is very, very simple. Okay, so what does that means? As my length increases, the flow of electron reduces. That means what? The current decreases. This is what I can say. Yes, of course. I hope you are able to understand this. This is very, very simple point. Okay, as the length of conductor, or I'll just write it in this way, as the length increases, the current decreases, that is overall resistance. Okay, if my current is decreasing, that means what? The resistance is increasing, that is the overall resistance that increases, right? Increases. I hope you are able to understand this. Very simple point. Okay, and when I say that my resistance is increasing, so what does that mean? Thus, what does that mean? Thus, what I can say, my length is directly proportional to the resistance, or in other words, what I can say, that is my R is directly proportional to the length. I hope this particular part is crystal clear. R is directly proportional to the length. That means what? As the length of the material increases, right? As length increases, so the overall resistance also increases. The overall resistance also increases. I hope this particular part is crystal clear. Okay, as the length increases, the overall resistance also increases. Okay, now we have 2 conclusions. That is, you see, my R is inversely proportional to the area okay, and at the same time my resistance is directly proportional to the length. What if I equate these two things, right? That is, let's say, what if I write it in this way, that is R is proportional to length, but at the same time it is inversely proportional to the area, right? And to remove this proportionality sign, obviously I need to put equals to sign, and there should be some constant. So let's say equals to, let's say this is my constant, some rho is L and A. So what is rho? Rho is nothing but resistivity. So rho specifies the resistivity. That means the how resistive that particular material is. Resistivity is nothing but how resistive that particular material is. Okay. So rho is the resistivity. Okay. L is the length of that particular material. A is the area. And with this we found a new formula, that is R is equivalent to rho L by. This is very important formula. You just need to remember this particular formula. Okay. And now I hope that you understood that how exactly this particular formula came. Most of the books, most of the guys out there on YouTube, they just bluntly teach you this particular formula, but they don't explain you that how exactly we can deduce this particular formula. It's very simple, right? Electronics, current, electricity, all of this part, you just need to have good imagination, good thinking skills, right? I know that at first it becomes a little tedious for you all guys, because we cannot see electrons, we cannot understand where the hell is electron is moving, right? Whether it is moving from point A to point B, point B to point A, right? Also there are few guys out there, they say current moves in this direction. Let's say if current moves in this direction, so your electron also moves in this direction. They will actually confuse you with lot of terms, okay? But believe me, it is one of the easiest topic. You just need to have a good thinking skills, right? Just need to try to relate the analogy that I'm explaining, right? As I explained right now the football pitch, right? Similarly in this case I explained the this particular analogy of water and this compressed pipe. So this is how you need to learn electronics. It's pretty simple, right? So with this we and this particular part, I hope you understood that what exactly is resistivity is. So what we can conclude, so length is proportional to R and resistivity is a kind of constant, right? This is what we saw. So this was all about the resistance. Yet there is one more part to discuss, that is the color code of resistor, right? How exactly a resistor looks like, right? How to identify the value or the magnitude of any resistor. I hope you might have seen certain resistors of, let's say, 100 ohms, 200 ohms, 1k. If not, don't worry, we'll see that. That's not a big deal, right? So how to identify the magnitude or the values of those particular resistors. So this is what we are going to deal with in the next session, okay? But I hope you really understood each and everything, each and every topic, each and everything that we have discussed till now. But still, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts in the communication section. I'll be happy to help you out there. So thank you for listening me patiently. I'm ending this video over here. Thank you.